Hello guys, this is problem 49 from chapter 3 homework, and the prompt is the voltage across. So we're actually going to go ahead and highlight some of the key points here, or just underline them at least. So the voltage across so we're given inductance. So we can say that L is equal to 10 to the negative 10. Henries, and then given by voltage, so we can say that our V of t is equal to 5 sine 10. I think there's a typo right here. I'm guessing that's 10 to the 6t. And the initial current, so we're given an I initial, which is negative 0.5 amps. Cool. And then basically it's asking us to find expressions for the currents. So I of t. Power, which is PL, since we're looking at an inductor, and stored energy, which is WL. Okay. So first, let's do the current. So we can say that we can find the currents by doing this. We can say that V of t is equal to the inductance di dt, and then we can solve for di dt, and then we're gonna go ahead and just do V of t divided by L, or over L. And then we can just plug in our known values here. Or actually, we're going to go ahead and just get rid of this dt, so we can integrate both sides with respect to dt. So this cancels this, and this is just going to give us I of t is equals to the integral V of t over L dt. And then let's plug in our knowns. So sorry. So it would be 5 I of t is equal to the integral of 5 sine 10 to the 6t div all over. We can just do 10 times 10 to the negative 6. This should be negative 6. I don't know why I said negative 10. Should be negative 6 up here. Actually, it shouldn't even be just that. It should be 10 times 10 to the negative 6. Sorry. There you go. Because it's yep. That should be fine. And then let's not forget dt. And then we can use an identity here, where I used the integral for sine x dx is equal to negative cosine ax over a. So if we were to apply this on our integral, we'd be left with negative, from the negative right there, negative 5 times 10 to the 5th cosine 10 to the 6t. And then we're going to go all over 10 to the 6. And then plus c. Then we can erase a lot of this and start back at the top. So we'll start back at the top. We can solve for c by plugging in I0 here. So we can say that I0 is equal to, actually, I think we could simplify that more. So we can just say that I of t is simplified to negative 1/2 cosine of 10 to the 6t plus c. All right, perfect. So now that we're given that, we can then solve for the c by doing I of 0 is equal to negative 0.5 amps. And then when we plug it in, we can just do negative 0.5 equals, actually I can rewrite this too. So negative 1/2 equals negative 1/2 cosine of 0, which is 1. And then we can do the plus c. Then we can isolate the c. Then we'll find that this is just negative 1/2 equals negative 1/2. So c is equal to 0. So we can just erase all of this. So this is just plus 0, so we'll just remove it. So we're given our IT, or we're given our current. So now we're going to solve for the power. So for the power, we can say that PL is going to be equal to the voltage multiplied by the current. So just say that IL. So we have our V. This would be VT times I of t. And then when we solve for the power and we multiply these two, let's just kind of write it out here. We have 5 sine 10 to the 6t multiplied by negative 0.5 cosine 10 to the 6t. Right. And then basically I just kind of used another identity here. I use sine x times cosine x is equal to 1/2 sine 2x, or I'll just do the 0.5 sine 2x so it's consistent. So in the end, it should leave us with negative 1.25 sine of 2 times 10 to the 6t. And that gives us our power. And then, and then finally, we can calculate for the for WL. Then we can say that basically our W is our stored energy, and our stored energy is just 1/2 times, oh my god, sorry, it would be 1/2 times the conductance, or sorry, the inductance, times IL squared. Right. So Again, we're just gonna be plugging everything in here, so we can just say that our W of t is equals to, let's just change this to 0.5, and then we're given 10 times 10 to the negative 6 for our L, right? And then for our IL, we're just gonna plug in this negative 1/2 cosine 10 to the 6t. So again, we're just gonna do 0.5 cosine 10 to the 6t. Oh, and there's a squared up there too. So then if we do the algebra, we're gonna end up with 1.25 times 10 to the 6 cosine 10 to the 6t. This should be joules. I just plugged this into my calculator. This should be joules. The power should be watts. The power should be watts, and this should be amps. Thank you.